Hello fellow chemists, Jolly here again. This video is going to be on the characteristics of ionic bonds. So what do we know about ionic bonds? Number one, they transfer electrons. They are composed of ions. Which the positive variation is called the cation. The negative variation is called the anion. They combine together to be neutral. All right, let's get to something we don't know. They are called salts, because it's a positive and a negative. So the reason table salt is called table salt is because it's an ionic compound, and sodium chloride is table salt. It happens to be ionic, and so it is called a salt. And table because that's the one that we use for food. So all ionic bonds can be called salts. Well, what about their ultimate characteristics? Here we go. They have high melting points. Why? Okay, this is an excellent question. Because it is the strongest attraction in nature. I'm going to put this in red. It's the strongest attraction in nature. A true positive sitting next to a true negative. Now beware, if you're in a biology class, you need to know which environment you're talking about, and biology is dealing with an aqueous environment, and so they probably won't say that an ionic bond or a true positive and true negative is the strongest attraction, because in that system they don't exist because it's floating around in water. But generically, ionic bonds they are the strongest attraction in nature. So therefore, those positives are very attracted to the negatives, and it's hard to break them apart, so they give really high melting points. They are all somewhat soluble in water. And you'd have to look at solubility tables if you wanted to know how much. But if they go into water, they are ions in aqueous environments. Now, I'm not saying it'll all be 100% soluble, but if any of it dissolves, they create ions in an aqueous environment. And so guess what? If they are in liquid form from being melted or dissolved in water, which we call aqueous, they conduct electricity. Yes, they do. And so that's kind of the basics behind an ionic bond. And there's a whole issue talking about solubilities and whether they'll dissolve 100% or just partially. But this, in a nutshell, talks about, what do I know about these ionic bonds? Now, let's just do a quick example. See if you can balance them. Now, this might seem like maybe an illogical thing to dwell on, but I have found it very, very, very important in my classes to be really, really, really sure, do you know what we're talking about? So what can you combine together to make ionic bonds? Well, let me see what I had. I had monoatomics, and I had both cations and anions, and I had polyatomics, and I had both cations and anions, and I can get even a little bit more specific, and these cations were metals, and the anions were either nonmetals. Don't forget some of the metalloids fall in there. All right, so I've got my metals and my nonmetals, or I've got my polyatomics. So any variation thereof will make an ionic bond. So let's try one. The most basic, the most basic definition is a metal with a nonmetal. Is that true? And the answer is yes. Now, just a little note right here. Cations are always written on the left, and the anions are always written on the right. So when I said metal, I was talking about cations, and nonmetal, I was talking about the anions. And don't forget the metalloids. That's my little asterisk right there. All right, so basically, how do you make an ionic bond? Well, you put a metal with a nonmetal. Don't forget the metalloids. All right, well, is there another way? Sure. Could you take a metal with a poly? Absolutely. The metal would be the cation, and you would have to choose an anion. Well, could I use a poly with a nonmetal? Don't forget the metalloids. Absolutely. And the last variation is I could do a poly with a poly. So even though the basic definition is a metal with a nonmetal, that's not quite the whole story. You do need to realize that any combination of a cation with an anion gives you an ionic bond. And I highly suggest you go through some of those problems. And I know it seems silly, but can you tell me the combinations of are these a metal and a nonmetal? Is it metal with a poly? You need to be able to predict whether it's an ionic bond or whether it is a covalent bond. And since I have a little bit of space here, I just can't waste space, I'm going to do calcium hydroxide. Is it ionic or is it molecular? Well, we haven't even talked about molecular yet, so it's probably ionic. How do you know that? Because it's the combination of a cation and an anion. Yes, this is ionic. But what is my combination? Calcium is a metal, and hydroxide is a poly. How about, let me see, zinc sulfide. Oh yeah, how about zinc sulfide? Well, zinc is a metal. Sulfur is a nonmetal. Oh, hey, it must be ionic. It must be ionic. Yay! Okay, that is how you would pick out ionic possibilities. So it's not just a metal with a nonmetal. You really need to understand the variations that you can get. And that takes care of our ionic bond basics. Until next time, jolly out.